Hello friends, welcome to the channel. I am Rohit. Hope you are doing good. Friends, in today's video we are going to talk about how we can configure IPv6 network in the packet tracer. So friends, in today's video we are going to see these several points. So first of all, we are going to see the introduction. Then we will see what are reasons because of which IPv6 come in the picture. Then we will understand what is IPv6. Then next to that we will see what is the difference between IPv4 and IPv6 in terms of their features. Then we will discuss the format of IPv6 address. Then we will learn how we can shorten the IPv6 address because IPv6 address is quite long. So how we can make it little bit short. What rules are there that we will try to discuss. Then we will see what are various types of IPv6 addresses. Next to that we will see what are types of unicast addresses in the IPv6 version. And at last I am going to discuss friends steps that we will try to follow in order to configure, in order to create IPv6 network in the packet tracer simulator. And then I will show you the actual practical demonstration regarding same. So friends, let's start the video by understanding what is IP address. So IP address is used as a unique identifier which is assigned to every device that is getting connected to a global network like internet. So over the global network, every device is having specific unique number by which that device is identified in the communication. So that is basically the IP address. So there is a protocol called Internet Protocol, that is IP, which is responsible for assigning IP addresses to a machine. So there are popularly two versions of this IP. One is IP version 4 and one is IP version 6. So in few past decades, primarily IP version v4 is being used for assigning these IP addresses to the computers. So IPv4 is basically using 32-bit addresses, and if we try to talk about the address space of IPv4, then we will have near about approximately 4 billion unique addresses available to the use. So friends, nowadays we have observed a rapid growth of internet, due to which lot of new devices are getting connected to the internet, and that's why we are requiring lot of new IP addresses, and because of which this 4 billion address space is getting exhausted. So this basic crisis we are observing with the IP version v4. So as a solution, there is a entry of IPv6 in the picture. So in December 1998, the Internet Engineering Task Force introduced the next version of IP, that is IPv6, as a solution to the address exhaustion crisis of IPv4 or address depletion problem of IPv4. So IPv6 is designed to replace IPv4 completely, and it will provide quite larger address space as compared to IPv4, as well as it has enhanced security and other lot of improvements as compared to IPv4. So whatever dilemmas, whatever problems, whatever downsides were there of IPv4, all that downsides, all that problems they are trying to overcome with its IPv6 version. That's why as a replacement to the IPv4, they have proposed IPv6 in 1998. Now let's try to understand what is IPv6. So IPv6 stands for Internet Protocol version 6. So this is basically the network layer protocol, and it is used for addressing limitations that were available within the IPv4. So IPv6 is the latest version that is available to use of IP protocol, and it is also referred as IPNG. IPNG stands for IP next generation, because whatever address space they have proposed with IPv6, so that address space will be available. It will not get exhaust near about in upcoming 100 or 200 years. That's why it is also referred as the internet protocol of next generation. So friends, IPv6 actually developed as an answer to many deficiencies that were present within the IPv4, like the address depletion or the exhausting addresses that are available in the address space of IPv4. So that problem they are trying to solve, that problem they are trying to answer with help of IPv6 version. Now next to this, let's try to understand few important differences between these two versions, IPv4 and IPv6. So the first point we have for making comparison between IPv4 and v6 is the address space. So as we knew, IPv4 is using 32-bit address. So if we try to compute 2 raised to 32, so it will give us near about 4 billion addresses. That is what its address space. So this address space is getting exhausted. Basically, that is what the problem we have seen. So as a solution, we have IPv6 with quite long address. So it uses 128 bit to represent the IP address. So if you try to compute 2 raised to 128, so it will be quite large value. This number of addresses will not get exhausted at least for upcoming 100 or 200 years. That's why we are saying, so IPv6 is actually the solution for address depletion problem of IPv4. So here the example of IPv4 address we have given. There are 4 groups of digits separated by dots, you can see. So every group can take value between 0 to 255. Likewise, we can present the address. So in case of IPv4, there are different classes of IP address like class A, B, C, D, E. And in case of IPv6, you can see there are actually 8 groups of hexadecimal values, and in every group there are 4 hexadecimal digits. So these groups are basically separated by these colons. So there are 8 number of groups you can observe. So here this is how the addresses look like in IPv4 and IPv6. Now next point we have in comparison, that is address depletion. So as we talk at the start of video, IPv4 is now running out of addresses. It's supporting only 4 billion addresses in its address space. So as a solution, we have IPv6, which is solving this address shortage problem or address depletion problem, and it is providing quite long value in the address space. So this is the second point. Third point we have regarding security. So IPv4 was not employing any security. Built-in security features were not there while transmitting data. So it was basically depend on the higher layer protocols. So if they use certain security protocol, then only security was available in the communication. But in case of IPv6, it is embedding IPsec protocol for implementing the confidentiality and data integrity in the communication. That is added advantage. So no dependency on higher layer protocol for secure communication. One more feature very important we have in the list, that is auto configuration. So in IPv4 there were no any auto configuration feature. Everything was based on manual configuration, or we can say manual configuration was required. But in case of IPv6, the host in the network can obtain their addresses and they can configure themselves with the IPv6 address automatically. That's why we can say IPv6 supports auto configuration. So these are few important points based on which we are comparing IPv4 and IPv6. But friends, in all these points, the key point is address depletion or the exhausting address space of IPv4, because of which they have proposed IPv6. Now next point we have, that is format of IPv6 address. So as we discuss, IPv6 is using 128 bit to represent the IP address, and in 128 bit IP address there are basically 8 groups of 4 hexadecimal digits as I shown in the previous example, and all these groups are separated by colon. So here we have shown you one example how IPv6 address look like. So here you can see this is the first group of 4 hexadecimal digits. Then this is the next group of hexadecimal digits. So these two groups are separated by a colon. Likewise, there are 8 number of hexadecimal groups. Okay, so this is how the IP address look like. Next point we have in discussion, like how we can shorten the IPv6 addresses. So you can observe IPv6 address is quite long. So they have proposed certain ways, they have proposed certain rules. By following that rules, we can make them little bit shorter if possible. So let's try to understand how we can make them little bit shorter by following rules. So rule number 1 is saying a leading 0 can be skipped. So for example, if you consider this IP address, so in this IP address, in this second group, you can observe it start with 0. Then in this next group, again, you can see there are 3 zeros. Then here in this group, there is 1 0. You can see these are the leading zeros. Then here at the last group, again we have 2 leading zeros followed by 4A. So according to this rule, we can skip these leading zeros. So if you remove all these leading zeros, your IP address will look like this. So you can see here in the second group, we have removed this leading 0. In this third group also, we have removed these 3 leading zeros. Likewise, in all subsequent groups, we have removed the leading zeros. In this way, we may shorten the IPv6 IP address. This is the first rule, which says you can skip the leading zeros. Now, let's try to see the second rule. In the second rule, successive groups of zeros can be replaced with the pair of colons. So, for example, here you can see there are 2 groups of zeros which are available in the successive manner, one by one, immediately. First group, immediately second group. So in this case, we may write these 2 groups with the pair of colons. So for example, how we have written this address, how we have shortened this address, you can see first group we have written as it is, that is 2002. Then followed by that, there were 2 successive groups of zeros. So instead of these 2 groups, I have written 2 colons over here, and rest of the address is as it is. So this is how we have shortened the IPv6 address. So friends, 2 rules we are telling you. One rule is saying leading 0 can be skipped. Second rule is saying successive groups of zeros can be replaced with the pair of colon. But there is one precaution we have to take, and that precaution is that we cannot use more than one occurrence of this double colon. So for example, observe in this IP address, this is the first group of successive zeros, and this is the second group of successive zeros. So if your answer is this one, as a shortened IP address of this one, then probably it will be wrong, because here you can see this is the first pair we have of colons, and this is the second pair of colons, which is not allowed, because if we do this, then there is no any way available to determine how many successive pairs of zeros are there in the IP address. That's why you may write the pair of colons instead of this successive group, or you may write the pair of colons instead of this successive group. So there are 2 possible ways by which this IP address can be shortened. So see this first way, here we have replaced this first successive pairs of zeros, and see this second IP address where we have replaced this second group of successive pairs of zeros. So any of this will be the possible shortened way of this IP address. So if you are shorten this first one, remaining zeros you may write like this 0 0 0, and if you try to replace this with the colon, then you may write 2 zeros here to represent these 2 groups. Like this we may shorten the IPv6 address. So friends, we will move forward and let's try to understand now which various types of addresses available in the IPv6. So friends, in IPv4 there were three types of addresses: unicast, multicast and broadcast. So unicast is conveying one-to-one communication, multicast is conveying one to specific group of host communication, and broadcast is conveying one to all. So these three types of addresses we knew from IPv4. Now in IPv6 we do not have any concept of broadcast addresses. Instead of that, they have proposed the concept of anycast address with multicast address. So there are total three types of addresses in IPv6: unicast, multicast and anycast. So first of all, unicast address, what they are? So unicast address basically identifies a single interface with which communication can be done. So packets will be addressed to that specific unicast address, will be delivered to only single interface. That is what we are saying, one-to-one communication. Then in multicast address, it is basically identifying a specific group of hosts which are part of communication. Like we have in IPv4, packets will be sent to this multicast address and will be delivered to all the interfaces that will be identified by specific multicast address. So in IPv6, always multicast address starts with double F. So whenever you will observe any address which is starting with double F, you understand that it will be a multicast IPv6 address. Third type of address we have anycast address. So anycast address is like multicast address. This also identifies multiple interfaces, but there is one difference. What is that difference? So whenever any packet is sent to anycast address, so whichever will be the nearest interface from the source in terms of routing distance, to that interface packet will be delivered. That is basically the difference between multicast and anycast. So in multicast as well we have multiple interfaces, in anycast as well we have multiple interfaces. That thing we have to remember. But in anycast, the delivery will be done to the nearest interface from the source. And how they are determining it? So based on the routing distance. This is basically the metric. So these are the three types of addresses in IPv6: unicast, multicast and anycast. Now we will move forward and we will try to understand the types of unicast addresses. So there are three types of unicast addresses in IPv6. First type is global unicast, second type is link local unicast, and third type is unique local unicast. So first type says global unicast. So these are the publicly routable IPv6 addresses similar to the IPv4 public addresses, and this global unicast address start with 2000. Then second type we have link local. So these addresses will be usable only within the specific network segment where that host is connected to. So link local address must be assigned to every network interfaces that are using IPv6 protocol for transmitting packets, for transmitting data, and these addresses are having prefix FE80. Last type of unicast address we have unique local. So these are having similar functionality like private IP addresses in the IPv4 version, which allow us to communicate between specific network segment as well as they are routable within the multiple local networks. So these unique local addresses begin with the prefix FD00. So these are certain types of unicast addresses that are available within the IPv6. Now friends, at the end of this theoretical discussion, I am going to discuss what steps we are going to follow in the packet tracer in order to configure IPv6 network. So first step will be enabling the IPv6 globally. So we have to go to the command line interface of router and we have to type a command IPv6 unicast-routing. So this command will enable IPv6 routing on that router and it will allow that router to process IPv6 packets. This is the first important command we have. Then second step, we will have enabling IPv6 on different interfaces. So for a router, whatever interfaces we are going to use, for all that interfaces we have to assign IPv6 address. So for that purpose, first of all, we will access the specific interface, like here I am accessing fast Ethernet 00, and then I am going to specify the IPv6 address for that interface. So our command will be IPv6 address. So in this address you can see we have used a pair of colons. So if you expand this IP address, so there will be near about 6 pairs of zeros. So next to that we will specify no shutdown command. So this command will ensure that whatever interface we are assigning with the specific IP address is up and is running. So this is the second step. So whatever interfaces you will have, same step you will follow. You will enable IPv6 address on that. Then next step will be configuring the IP addresses for host that we will have within our network. So simply we can go to the desktop IP configuration, and over there we can assign IPv6 address. So these are the overall steps that we will follow in order to create IPv6 network in the packet tracer. So friends, now I will take you to the packet tracer, and over there we will try to create one simple IPv6 network, and also we will try to test it whether it is working or not. So friends, we have this new file available with blank workspace, and now first of all we will add one router in this network. So we are going to assume this 1841 router, and we will assume 2 machines here. So let's say this is the first machine, this is the second machine. So with this 3 components we are going to form a IPv6 network. So let's try to connect them quickly with each other. So I am going to use this first option, clicking on this machine and taking this to the router. Connection is established. Again I am going to connect this router to the second computer. So now our connection is ready, and now quickly we will try to put the notes regarding what IP addresses they will have. So I will select this note, and let's try to place note for this interface FA00. So let's say here we will have IP 2004:1/64. Now I will copy this. So here I will have IP address 2004:10/64. Now for this second interface, let's say we will have IP 2008:1/64. For this machine we have IP 2008 : okay, by mistakenly I have typed something else, 2008:10/64. So this is how we have given the IP addresses to all the interfaces we have. Now friends, we will go to the command line interface of this router, and we will assign now IP addresses to both of these interfaces. So first interface we have this one, FA00, and second interface we have FA01. So FA00 is connecting to this side of network, and FA01, this interface, is connecting to this side of network. Okay, so we will click on router, and here we will go to the CLI tab. I will maximize it, and now it is asking you whether you want to enter in the initial configuration, so I will say no. Okay, now here first command we will type is enable, so which will allow us to enter in the configuration mode. So here I will type next command configure terminal and hit enter. Now you can see you are in the configuration mode. Now first of all, as we discussed in our steps, we have to enable the IPv6 address here globally. So we will use this command IPv6 unicast routing. So now here we are going to specify IPv6 unicast-routing and hit enter. Now friends, we need to configure the first interface of our router. So I will show you, this is the first interface FA00, so we need to access it. So here I will type now command interface and start typing fast. It will complete this by pressing the tab. So you can see now interface fast Ethernet 0/0 and hit enter. Now you can see you are in the configuration mode of interface. Now here we need to specify the IP address for this interface. So for that we will type here IPv6 address, and what address we have specified here, 2004:1/64. So hit enter after this, and after that I will type no shutdown. So it will make ensure the interface is running and it is up. So hit enter. Now you can see this interface is up now and it is running. Now this interface is still down. We need to enable now this interface. You can see the red symbol which is showing that this interface is down, and here you can see green symbol which means the link is up. So in order to configure this interface, again same commands we need to follow. So here I am going to type interface, interfaced, name of interface is fast Ethernet and 0/1 and hit enter. Now we will specify address IPv6 address, and in our network design we have given IP 2008:1. So here we will specify 2008:1/64. Hit enter, and now you type no shutdown. Hit enter. You can see now link got up. Both of the links are up now. You can observe this is what we have in the router configuration, friends. So now I will close this because both of the interfaces we have configured. Now friends, this is time to configure now both of these hosts. So click on this first host and go to desktop IP configuration. Now here you have to observe this IPv6 panel, and here we will specify the IPv6 address for this machine which we have decided, 2004:10 followed by length of subnet 64, and default gateway for this machine, this will be the default gateway. So 2004:1. So this is what we have in the configuration of first host. Okay, now close this. Come to the second machine, desktop, again IP configuration, and here we have IP address 2008:1 0 followed by 64, and for this host the default gateway is this one, 2008:1. So both of the machines we have configured. Now let's try to test by using ping command. So from this machine 2004-10 we will try to ping this second machine, that is 2008-10. So we will go to the command prompt of this machine, and here I am going to type ping and destination address, so 2008:10, and try to hit enter. Now you observe here you are getting a reply from the destination machine. 4 packet we sent and 4 packet we have received. Same thing we can do from this machine as well. So let's try to ping this machine from this machine. So here we will click on this machine, go to command prompt, and now our destination is this one, 2004-10. So here I am going to type ping, destination is 2004:10, hit enter. You can see you are getting reply from destination. So again 4 packet were sent from source and we have received reply for all the packets. So friends, this is how a simple IPv6 network we have configured and tested within the packet tracer. So friends, if you find this video useful, please like and share this video. If you are visiting this channel first time, please hit the subscribe button and share this video with your friends. Thank you for watching this video. I will see you in next video.